Okay, so we're going to get into talking about algebraic structures by first looking at symmetry. Now, symmetry is something that shows up in the world in lots and lots and lots of different ways. A really simple way is if you think of a perfectly symmetrical face. Here I've drawn one side in green and one side in orange, just so that I can show you that when I flip the face over, I get exactly the same picture back, but, with those two sides reversed. So a symmetry is just a way of moving a thing back onto itself so that you don't change the thing. So it's a transformation that doesn't change it. It leaves it invariant. Another example is a tiling. So if you think of just, some black and white tiles tiling, a nice house or a bathroom or something like this, you can imagine that tiling pattern going on forever in all directions. And once it goes on forever in all directions, you can take the whole tiling pattern and move it over by some amount back onto itself in such a way that you haven't really changed it. You move the black tiles onto the black tiles, the white tiles onto the white tiles, and everything's okay. It's very, very symmetrical. You can do this over and over and over again. A bit more of a complicated example is if you think of physics. Physics, the rules that govern the way that things move in the world, has lots and lots of different symmetries in it. In fact, all kinds of symmetries. But I'm just going to think about bouncing balls for a moment. Now, let's imagine that you're in, say, Kenya, and you drop a ball somewhere, maybe in Nairobi or something. So you drop your ball, it falls down, and it bounces. Now, the rules that govern that bouncing are exactly the same as if you're, say, in Italy, standing on top of the Leaning Tower of Pisa, and you drop a ball there. And it comes down to the ground, and it bounces a bit, and everything's cool. It's exactly the same physics. And what that tells us is that if you were to take the Earth and just sort of, rotate the Earth back onto itself, so that Kenya moved to Italy, where Italy is, the physics is the same after that rotation. So the physics is invariant under that rotation, which tells us that there's a symmetry there. There's a kind of symmetry. There's actually all kinds of different symmetries in physics. This is just one. You think of the Earth moving around the sun, the physics is going to be invariant under that as well. So your exercise is to find more examples of symmetry around you. Now, that doesn't have to be as complicated as our physics example, but maybe just something that looks the same when you move it back onto itself.